in the notation chart. Decimals represent values that are less than 1. When rounding decimal numbers to the nearest hundredths, we look at the digit in the thousandths place, or as I like to say, the digit hitting on the back door. If it's 5 or more, add 1 to the hundredths place and change all digits after the hundredths place to 0. If it's less than 5, write the decimal as it is, and all digits after the hundredths place becomes 0. Let's quickly go to this example. Round 34.237 to the nearest hundredths. Now let's identify the number that is in the hundredths place. The number in the hundredths place is 3. Let's identify the number in the thousandths place. The number in the thousandths place will tell you what you have to do if you rewrite the fraction as it is or if you add 1 to the hundredths place. The number in the thousandths place, in this case, 107. Is 7 more than 5 or is it less than 5? 7 is more than 5. So we add 1 to the number in the hundredths place. The number in the hundredths place is 3. So that 3 becomes 4. 34.237 rounded to the nearest hundredths is 34.24. Let's look at another example. Round 45.623 to the nearest hundredths. What number is in the thousandths place? 3 is in the thousandths place. What number is in the hundredths place? 2 is in the hundredths place. Is the number in the thousandths place more than 5 or is it less than 5? The number in the thousandths place in this case is less than 5. So once the number is less than 5, we write the fraction as it is. So 45.623 rounded to the nearest hundredths is 45.62. Boys and girls, I want you to complete this activity for me. Round the numbers below to the nearest hundredths. Round the numbers below to the nearest hundredths. Remember, when rounding to the nearest hundredths, you identify the value that is in the hundredths place and you identify the number that is hitting on the back door, which would be the thousandths place. That number will tell you if you will add 1 or write the decimal as it is. Take a minute and get this done, boys and girls. You should be finished by now. 234.465 rounded to the nearest hundreds is 234.47. Why? What number is in the thousands place? 5 is in the thousands place. And we said once the number is 5 or more, we add 1 to the hundreds place. And the number in the hundreds place is 6. So when we add 1 to that 6, it becomes 7. So 234.465 rounded to the nearest hundreds is 234.47. 345.234 rounded to the nearest hundreds is 345.23. Now, boys and girls, why? The number in the thousands place is 4. It is less than 5. When the number in the thousands place is less than 5, when we are rounding to the nearest hundreds, we write the decimal as it is. Boys and girls, this has brought us to the end of our class for today. But wait, before you leave, my little problem solvers, here is the problem of the day. Dave had a rope measuring 678.367 meters. Estimate to the nearest hundredths the amount of rope Dave had. Take a minute and do this, boys and girls. Should be finished by now, my little problem solvers. 678.367 meters estimated to the nearest hundredths is 678.37 meters. Boys and girls, do you have that answer? I hope you did. Now, this is the end of today's class. Remember to always be kind. See you next time, boys and girls. Take good care of yourselves.
The only way to learn mathematics is to do mathematics. Hello, boys and girls. My name is Miss Aliyah Brewster, and today we'll be examining the concept of ordering decimals. So grab a pencil and your notebook, get settled because we're about to start. Are you ready? I'm ready. Let's begin. First of all, we'll examine the concept of decimals by defining what decimals are and examining the place values of each decimal so that you can be better informed and better equipped to order the decimals. Decimals are a way to show numbers less than 1. Place values show the value of each number before and after the decimal point, such as tenths and hundredths. Now, if you look at the image, you would notice that the number that's up on the screen there is 28.531. 28.531. We do not say 28.531. That would be incorrect. So whenever you're calling the numbers after a point, you call them individually. So the number again is 28.531. In that number, you would see that the numeral 2 represents tens and the numeral 8 represents the units or ones as we know it. And then after the 8, there is the decimal point. After the decimal point, you'll see number 5, and 5 represents, the place value of 5 is tens, and the place value of 3 is hundreds, while the place value of 1 is thousands. Now, numbers that go before the decimal point are 10 times bigger as they go further away from the point, while numbers that are after the decimal point becomes 10 times smaller the more they move away from the decimal point. Look at the other image on the screen. There you would see some colorful cubes. The first cube, which is a large cube, is used to represent whole numbers, such as the one in the figure 28.531. The whole number there would be 28, while the flat image or the square is used to represent tenths. Those are the numbers that come exactly after the point. In this case, in the case of the number 28.5, that number would be 5. Then you have the long rectangular image that is used to represent 100, while the small cube is used to represent 1000. Now below, there's an enlarged image of what was explained just now. So here we have it in a numerical value. The large cube there, you see it is represented by the whole number 1, while we have the smaller cube or the flat image, which is used to represent the numeral value after the point. And then there is the long rectangular image, which is used to represent the second number after the point, while the third image represents the third number after the point. Now, the idea that you're supposed to be grasping here is that each number within a decimal number has its value. Now we'll move on to comparing decimals. To compare decimals, we have to use our eyes. You have to look at the numbers and differentiate which one is bigger or perhaps even which one is smaller. In this example, we have the numbers 7.54, and then we also have the number 5.94. In this case, the whole numbers 7 and 5 are different. Therefore, 7 is greater than 5, meaning that 7.54 is the bigger number. In this other example here, the situation is different. We have two numbers, however, the whole numbers are the same. 20.69 and 20.23 are the numbers we'll be comparing. So in instances where you have the whole numbers that are the same, you have to look at the number that comes after the point. In this case, those numbers are 6 and 2. 6 is greater than 2, therefore the number 20.62 is greater than 20.23. Now that you understand a little more about decimals, I would like you to try this activity on your own. Using the symbols below, compare the decimal numbers. We have greater than, less than, and equal to. For number 1, you'll be comparing the numbers 0.4 and 0.7. Number 2, you'll be comparing 5.6 and 5.9. Number 3, you'll be comparing 24.39 and 24.37. Answers. So for your activity, I hope you're finished. Here are the answers. Number 1, we learned that 0.7 is greater than 0.14. While for number 2, we learned that 5.6 is less than 5.9. While number 3, 24.39 is greater than 24.37. I hope you got all correct. Now we can move on to ordering decimals. For this activity, you'll be arranging these numbers in ascending order. One study tip is that ascending order means to arrange numbers in an increasing order, that is, from smallest to largest. For A, the numbers you're given are 7.2, 9.1, 3.1, 11.9. Letter B, the numbers that you are giving are 23.1, 5.3, 7.23, 7.21. The last activity, the numbers are 0.1, 100.3, 7.23, 6.2. Did you get all correct? Here are the answers. For the first activity, the correct order is 3.1, 7.2, 9.1, followed by 11.9. For the second activity, the correct order would be 5.32, 7.21, 7.23, and 23.1. While for the last activity, the correct order would be 0.1, 6.2, 7.23, 100.3. That has brought us to the end of this lesson, boys and girls. Remember, to learn mathematics, you must do mathematics. This simply means that even though our lesson might be over, your study time is not over. In order to be successful at your upcoming exams, you need to practice, practice, and practice some more. Thank you very much for tuning in, and goodbye.
Oh, hello, boys and girls. It's a really hot day today, don't you think? On a hot day, I love a refreshing glass of Swank. Yummy! To make my Swank, these are the ingredients that I use: a mug of water, limes, essence, and sugar to taste. After combining my ingredients all together in the mug, I stir until everything disappears. Then I pour a nice tall glass with cube ice. Refreshing. Boys and girls, welcome to our grade 5 science class today. My name is, as you know, Miss Yulita. I have taken a break from maths to teach you some science. Can you guess what is our topic for today? Yes, our topic for today is mixtures. In the beginning, I explained that I love a tall glass of Swank on a hot day. What I meant in actuality was a mixture. So let's look at some key terms. What are mixtures? Mixtures are combinations of two or more substances without a chemical reaction. In some mixtures, you can see the different materials, and in some, you can't. Almost all of the things around us are mixture. Notice I said almost. Yes, almost all of the things around us are mixtures. Let's look at an example. In the mixture of a salad, you can see the different items used to make the salad, like the lettuce, the onions, the tomatoes. Some people put raisins, some people put nuts. This is a healthy mixture and it will do good for your body. Let's take, for example, a mixture of M&Ms. This is a mixture of M&Ms with different colors. The two mixtures I shared with you are mixtures of solids. What sets mixtures apart? Take into consideration the Swank that I made. Do you usually see the particles in the glass when you are ready to drink it? No, they all look the same. This is an example of a homogeneous mixture. Yes, that is a big word, homogeneous. Homogeneous mixtures are mixtures that have one appearance because the particles are usually distributed evenly. Some mixtures may be called solutions, while some may be called suspensions, or colloids, or emulsions. In the mixture of the swank, the water, the lime juice, the sugar, and the essence, in the end, we could not identify the materials because it had already evened out. The glass of lime juice is a good example of a homogeneous mixture. Also, a salt solution, water plus salt dissolved in the water equals a salt solution. That is another example of a homogeneous mixture. Let's zoom in a little closer. Today we will be focusing on mixtures where we cannot see the substances when they are combined together. Such mixtures are called solutions. What is a solution? A solution in science is a mixture of two or more substances that are distributed evenly among themselves. In other words, it has one appearance. When a solid dissolves in a liquid, notice the word I use, dissolves. When a solid dissolves in a liquid, a solution is formed. In science, we don't say that solids melt in liquids, they dissolve. The solute is the solid part of the solution. This is the substance that dissolves. The solvent is the liquid part of the solution. This is the substance in which the substance dissolves. So, the solute in the salt solution would be salt and the solvent would be water. Some materials that do not dissolve in solvents are said to be insoluble. Example, could a mixture of bricks and water even out? No, bricks are insoluble in water. When you make the mixture, you will see the bricks settling to the bottom of the container. So a simple equation to state what we just learned is solute, or the solid, plus the solvent, or the liquid, equals to a solution. Water is a very common solvent. However, some substances do not dissolve in water, but they dissolve in other substances. Let's look at a few examples. Gas in gas, that's a solution. An example of that is air. Oxygen dissolved in nitrogen gives us air. Gas in liquid. Water, oxygen gas dissolved in water. Gas in a solid. Ice, oxygen gas dissolved in ice. Liquid in a gas, humid air, hot air, water dissolved in air. Liquid in a liquid, alcohol, ethanol dissolves in water, gives us alcohol. Liquid in a solid, dental fillings that the dentist would use. This comprises mercury dissolved in silver, solid in liquid, salt water, salt dissolved in water, or sugar dissolved in water, solid in solid, metal alloy. Bronze dissolved in copper would result in metal alloy. So boys and girls, you see that water is not the only solvent. Some substances dissolve in other substances. Boys and girls, it is time for us to go to our science lab. Grab your lab coats, grab your beakers, your notepad, and your pencil. But before you go, let's look at the safety note for today, because we know that safety comes first if we are heading into the lab. Many household products are mixtures or solutions that contain